What do we know about the sides? Yeah, they're all the same. So if HK is 12.4, KJ is also going to be 12.4. And HKL, that's this angle here, is 39, and we want to find LKJ. Now the diagonals are going to do what to the angles? We're going to bisect both of the angles. So LKJ is going to also be 39. So all four of these angles would be 39 degrees. Okay. Questions on that at all? Okay, and if we have a square, MNQ, that's this angle here, is 45. And then QPO is going to be, yeah, 45. In a square, because every angle is 90 degrees, if you have diagonals, that makes every new split. These will all be the same. They'll all be 45 degrees. And then if QO is 23, so that's this part right here, 23, the whole thing is going to be 46. Okay, so the trapezoid is a quadrilateral with exactly one pair of parallel sides. And so when we look at the picture, we'll show all this. Bases are the parallel sides of the trapezoid. Legs are the non-parallel sides. Base angles are the pairs of angles formed by a base and the legs. And there are two pair of base angles in each trapezoid. An isosceles trapezoid has congruent legs, and a median joins the midpoints of the legs. Here we have our trapezoid. These are the bases. This is a leg. This is a leg. And then we have our base angles. This is one pair of base angles. This is another pair of base angles. So wow, that looks terrible. So we have two pair of base angles, two bases, two legs. Now in an isosceles trapezoid, your legs are the same length. And in an isosceles triangle, or trapezoid, you have base angles that are congruent to each other. In a standard trapezoid, these are not necessarily congruent to each other. So okay, and that's theorem 54, is that each pair of base angles in an isosceles trapezoid are congruent. So these two are congruent to each other, and these two are congruent to each other. The diagonal of an isosceles trapezoid are congruent. I think we have that. No, we don't have a picture of that. Okay, let me draw a picture of that. It's not isosceles. Okay, we'll pretend that's isosceles. So if this is isosceles, our diagonals So AC will be congruent to DB. That's theorem 55. And the median of a trapezoid is parallel to the bases. So here's our median. And it connects to the midpoints, so it cuts each leg in half. And the length is half of the sum of the length of the bases. So the median is equal to base 1 plus base 2 divided by 2. If this is base 1, not base I. Base 1, and this is base 2. So this is the formula for the length of a median. So we have this LMNO is a trapezoid and it has a median of PQ, and we want to find the following. LM is 8, so that's this entire length. We want to find PM. We want to find that length there. Well, our theorem tells us that these two are going to be the same length. Sorry, our definition of median. So if LM is 8, PM is half, so PM is 4. More trapezoid stuff. If BC is 34, that's this whole length, FC is going to be half, so that's 17. All right, we have that ABCD is an isosceles trapezoid, so that means that these two legs are the same length. ADC is 59 degrees. That's this angle here. This angle, this angle, this angle, and this angle will all be the same. Likewise, these four angles will all be the same. So if I have ADC is 59, BCD, which is also going to be red, so that'll also be 59 degrees. And then just like when we had our parallel lines with the transversal, the same colors are all the same, and opposite colors will add up to 180. So if we had to find, this angle here, knowing that this was 59, we'd just subtract from 180. AB is 16, DC is 24. So these are bases. If this is base 1 and this is base 2, EF is the median. So EF is equal to base 1 plus base 2 divided by 2. So that's 16 plus 24 divided by 2. So it's going to be 20. Okay. And finally, if DAB is 109, and that's a blue one, and I want to find DEF, they're both blue. So also 109. Questions on any of that? LM is 18. That's this whole length here. So what's PM, this length here? Not quite. 9. 9. Yeah, close. Excuse me. NQP is this angle right here. NOL is this angle here. What do we know about these two angles? They're the same. Okay. MN is 24 and LQ is 38, so we want to find PQ. So we add the bases, divide by 2. MLO, that's this angle here, is 61, and we want to find LPQ. That's this angle here. What do I know about these two angles? They're opposite, so they're going to add up to 180. So I'm going to do 180 minus 61. So 119. And then NQ is 7.5, so NO 15. Because we're going to multiply by 2. Called a mid-segment theorem with triangles. So the segment that joins the midpoints of two sides of a triangle is parallel to the third side and half the length. So PQ is going to be parallel to CB. And PQ is going to be 1/2, sorry, this needs to have that on top, of the size of CB. And every triangle has 3 mid-segments. Okay, because if I put a point halfway between C and B and I call it, I don't know, M, in this particular triangle we'd have PQ, PM, and QM. Because we could draw a mid-segment here, and we could draw a mid-segment here. Does that make sense? If I did draw this PM, PM would be parallel to AB. Did you see that? PM, AB. And it would be 1/2 of the length of AB. And then QM would be parallel to AC. And it would be 1/2 of the length of AC. If UV is 11, so this length here is 11, I want to find XV. This is a mid-segment, so this is a midpoint, so what do I know about these two parts? They're going to be the same, right? So I'm going to divide by 2. So XV is 5.5. Now if I have a midpoint Z, and I draw this mid-segment this way, ZY is 1/2 of UV. So what I end up with are 3 parts that are all the same length. And this UZ and ZW is going to be the same as XY. See that? Okay. Okay, so did you guys get 6, 10, and 28? Awesome. Did you try D? Okay, so let's look at D. D is a little bit complicated, but this is as complicated as they get. So we have BC, that's this whole part, is 4x minus 2. And then EC, that's this little part here, is 3x plus 1. EC is 1/2 of BC. right? So if I take EC and I multiply it by 2, it'll equal BC, right? So far, so good? Like if this was 5, the whole thing would be 10. So in order to solve for this, I need to multiply EC times 2. And that'll equal BC. So then I'm going to distribute that 2. Subtract 4x from both sides. And I get 2x plus 2 is equal to negative 2. So I subtract 2 from both sides. And I get 2x is equal to negative 4. So I get x is equal to negative 2. But we didn't ask for x, we asked for BE. Well, BE is the same as EC, correct? EC is 3x plus 1. So I plug that negative 2 in. So I get negative 6 plus 1. That's 2. So I get negative 5. Now, this problem, honestly, was not set up well because you should never get a negative number technically because distance or length can't be negative, but we did it right. It just wasn't written well. So don't worry too much if you get negative answers on these. This is one of the ones I'm going to have to go in and correct. X is 4 and y is 16. Perfect. Okay, so now we're going to have inequalities in 1 and 2 triangles. So we have inequalities inside the same triangle and then inequalities between 2 triangles. So we have what's called the exterior angle inequality theorem. What that states is that if I have a triangle with an exterior angle, and let's call these angles 1, 2, and 3. Angle 1 is going to be greater than angle 2, and angle 1 is going to be greater than angle 3. And if you think about this, it will make sense because we had that theorem that said angle 1 was equal to 2 plus 3. Well, if angle 1 is equal to those two added together, it has to be bigger than either one by itself. All right, then we have another one that states if we have a triangle, and let's call it triangle ABC, and then the sides opposite of each of these are little a, little b, little c. What this theorem tells me, let's say that A is greater than B, right? So this side, that's not right though. Let's say B is greater than A because that's actually true. So if B is greater than A, then the angle opposite of little b, so that's angle B, is going to be greater than angle A. And opposites are across from each other, so opposite side is like that. Theorem 60, okay, so Theorem 59 and Theorem 60 are basically the same thing. So if I have A, B, C again, and little a, little b, little c. This one, Theorem 59, said that if the side A was or side B was larger than side A, then angle B is larger than angle A. This one goes the opposite. This one says if angle B is greater than angle A, then the side little b is greater than the side A. Oh, wait, I messed up my B and my C here. Sorry. So if this angle is larger than this angle, then this side is larger than that side. So we've got the same opposite thing happening. It's just going the opposite direction. So instead of going from side to angle, now we're going from angle to side. So now we have triangles, inequalities in two. Oh wait, sorry. This is still one triangle. My bad. Okay. Basically what this says, the length of any two sides is greater than the third side. So A plus B is going to be greater than C. B plus C is going to be greater than A, and A plus C is going to be greater than B. And if you think about it, that makes sense, because if A and B were shorter than C, it wouldn't go all the way to the other side, because like the length of C, if A and B were exactly the length of C, it would lay flat. There wouldn't be anything to peak it up. So if they were shorter than that, it would be like they would come in and do that, and they would never go to the other side. So it wouldn't be a triangle. Now we're getting into the two triangle theorems. Okay. So I have, let's say I have this length congruent to this length, and this length is congruent to this length. And this is angle A, and this is angle B. And this is little side A, and this is little side B. If this is true, that these sides are congruent, so the congruency between the two triangles, and then angle A is, well, I didn't draw it that way, so I drew it angle B. So if angle B is larger than angle A, then side B is going to be larger than side A. Now, that only is true between two triangles if the other two sides are congruent. And it's the side angle side inequality because we've got side, side angle, side, side angle, side. All right, then we have side, side, side inequality, and that's telling us if this side is congruent to that side, and this side would be congruent to this side. If A, the side A, is greater than the side B, then the angle A is greater than the angle B. So it's basically the exact opposite of side angle side, whereas there it said if the angles were larger, that made the opposite sides larger. Here, if the sides are larger, that makes the opposite angles larger. And it's side, side, side because we're looking at the sides to figure out the angles. So we have side, side, side. How do we use triangle inequality theorem? Well, the theorem says that the sum of the lengths of any two sides has to be greater than the length of the third. So to tell if this can be a triangle or not, we add them. So 3 plus 4 needs to be greater than 5. Yeah, it is. 4 plus 5 needs to be greater than 3. Cool. 3 plus 5 has to be greater than 4. Yes. All three are true, so yep, it can be a triangle. If any one of these was not true, it's not a triangle. We can do this to identify the largest angle or the longest side. So if we're looking at, this one's for A, this one's for B, this one's for C, and this one's for D. Okay, if we're looking at this triangle for A, we want to find the largest angle. First, we find the largest side. Largest side is 23, right? So the largest angle is B. To identify the shortest side, first I need to know all the angles. So I'm going to do 180 minus 59 plus 58. And I'm feeling kind of lazy right now. Oops, plus 58. So this is going to be 63. So to find the shortest side, we find the smallest angle, which is 58. So that makes the shortest side MO. Now, this one is going to require a little bit more work. Okay, I see that this triangle, the big triangle, is isosceles, so that tells me this is 46. So I'm going to use the fact that this is 46 to find this angle here. So I'm going to do 180 minus 46 plus 51. So that's 180 minus 97, which is 93, no, 83. So that's 83. Once I found this angle, I can then find this angle by subtracting from 180. So 180 minus 83 is 97, which lets me find this angle. So 180 minus 83 is 97, and then 180 minus 46 and 97 will tell me this angle here. So 180 minus 46 minus 97 is 37. And we want to see which is longer, AB or BC. 37 goes to BC, 51 goes to AB. So which one's longer? AB. And then finally we want to find out which angle is longer, angle 1 or angle 2. Angle 16 goes to angle 1, or side 15. Side 16 goes to angle 1, side 15 goes to angle 2. So which one's larger? Angle 1, because it's slightly longer side, so it's slightly larger angle. Such